Okay, table 3, choose a whole number between 0 and 10. 7. All right, and you could have picked any number so long as it's between 0 and 10 and it's not a decimal, then you could have picked another number for number 1. But the next question says evaluate the expression using your number for x. So that's what we're going to do. Anywhere that there's an x, we're going to plug in a 7. At least that's what table 3 picked. You could have picked a different number. And you could do order of operations yourself. I wouldn't really recommend it. And like tomorrow, for example, unless you bring a calculator with you to testing, then you're stuck using that janky calculator that's in the Aspire platform. So the one that's in the Aspire platform can do order of operations for you. Still, you just have to know exactly how to use it. And what I don't like about that one is that you have to hit the multiplication symbol in between like this 2 and this 7. It will not just assume that parentheses are multiplication. So that's why, like, if you haven't checked one out from the bookstore, I would do that today because you won't have to speak. Okay, so bring one with you tomorrow, so that you can practice using it. You will not have Desmos on your ACT Aspire Math, unfortunately, but there's lots of calculators out there that let you see what you typed in, and that will do the order of operations for you. So let me put that in parentheses. So 7 squared minus 2 and 7. And if you're using the Aspire calculator tomorrow, you'll hit that times button. And then minus 35. And that does give me 0, which the next question says, if your number doesn't give a value of 0, look for someone in the room and ask them if the number they chose makes it 0. So we already got it first try, so we don't have to do that, but that's what you would have done if you didn't get it right off the bat. The number that does that is 7. And the reason why we care is because in that very first equation, it was already equal to 0. So 7 is a value that makes it true. Now, number 4 says that there's another number that would make the expression true. What is it? So did anybody find the other number that makes this expression equal 0? Jordan? -5. And how'd you find it? Guess and check, which works. But we've seen before that if the solutions happen to be decimals, guess and check is kind of difficult. But as you can see, they're not decimals, so guess and check is a reasonable method for that. However, today's lesson is called Solving Quadratic Equations by Using Factor Form. So let's practice that now, using factor form to solve the quadratic. You can also, if it just wants the solutions, you can also graph it and know where to look on your graph, but we're going to practice with the factor form. So in order to factor, it needs to be set equal to 0 already, which it is. And then look at what you're given. I don't have a GCF that I need to factor out. Usually you check for that first. No GCF. So if I have a trinomial in this format, how do I factor it? What method do I use to factor it? If it looks like this. Right, we learned how to factor all last week. So we're going to now mix the factoring methods together. So anytime you're factoring, first check for a GCF. If there is one, factor it out. We don't have one. So after you factor out your GCF, you check how many terms you have. So far, we've learned how to factor a 3-term expression and a 2-term expression. How do I factor my 3-term expressions? All of you. I can tell you if you're right. How do I factor a 3-term expression? All right, so everybody look up here, stop ignoring me. How can I put the standard form back into factored form? How did we learn how to factor this last week? The diamond method, the one with the X. That's the one where we set it up where it's A times C on top, B on the bottom. And what's my A for this one, class? Good, my A is 1. Remember in unit 6, first thing we did usually was identify our A, B, and C. So A is 1, what's my C value? Class, more people should be answering. These are super easy questions. You guys are making it difficult. What's my C value? Not 0. Negative 35 is correct. Now multiply my A and C together. What's 1 times negative 35? And now what's my B term from my standard form? Negative 2. And that's how you set it up. It's kind of like a puzzle at that point. So we're looking for 2 numbers that multiply to negative 35 and at the same time add to negative 2. Now C, do the numbers we chose earlier, do they do that? 7 and negative 5? Do they multiply to negative 35? Do they add to negative 2?
Wait.
They don't. They don't add to negative 2. The way that they would add to negative 2 is if I made the 7 negative and the 5 positive. Now, why might that be? Because remember, this gave us the factored form. So the factored form of this is x minus 7, x plus 5. Does everyone see that? My factor form, remember that's why we did that, so we could get the factor form. But for our solutions for the values of x that make it true, our solutions are still 7 and negative 5. Because that's what x has to be to make it 0. All right, so know the difference. Don't just like do the diamond method, look at this and say that these are the answers. Because really, it's actually the opposite signs are the answers, right? Because what minus 7 will give me 0? 7. And what plus 5 will give me 0? Negative 5. All right, so really, and if you don't remember the patterns, you would set each factor equal to 0 and solve for x individually, right? So like add 7 to both sides. That's why one of our answers is 7. Subtract 5 from both sides. That's why one of our answers is negative 5. All right, so that's how you solve it by factoring, which we'll write out the steps in the next problem, but it's really important you know how to do that because the questions on your test will not just ask for the final answers, which of course you could get the final answers by graphing. It'll say, where did this student make an error? It'll say, what's the correct first step? And you have to know how to like fix that. But to finish this little flow chart that I was making, You factor based on the number of terms. There's different strategies. So it's 3 terms. That's when we can use a diamond method. If it's a 2 terms, that's where you check to see if it's a difference of squares. And then if you do see that it's a difference of squares, you put the square roots and 1 plus, 1 minus. That's the lesson we did Friday. How to factor 2 terms. Okay. But today, like I said, we're doing lesson 9. You have a practice for it in Schoology. And then today is the last day to submit any ACT Aspire, like extra credit IXL skills. That practice test that's in there, any corrections that you wanted to submit would have to be done by today. You could submit them online if you have to, because tomorrow's when you take your real ACT Aspire math. So make sure you get a good night's sleep. Make sure you show up early tomorrow, that you know where you're going, and use all those testing strategies we talked about. So like pacing yourself, skipping all the ones you don't know how to do, but at least guessing on them. Don't just leave them blank. Guess on them all by the end. But try the ones you know how to do. If you don't know how to do it, come back to it later. But you have 75 minutes tomorrow. Make sure that you're timing yourself accordingly. It's like 1.5 minutes per lecture. Madison? You had your hand up earlier? Good. Okay, so moving on, next activity. We had to see how Tyler wrote out the following steps to solve this equation and analyze his work. We're going to write down what he did in each step. So notice we've kind of just been talking about it and doing it this whole time. We're going to give you some steps to memorize and follow now. So first, take a look at the original equation. Next, see what the difference is from the first line to the second line. What's the difference? Let's tell me what he did. Just tell me what's the difference between the first line and the second line. Kristen?
He moved over the 99.
He moved over the 99. So the difference is that before it was equal to 99, and now it's equal to 0. And then also look, the 99 ended up over here and it's negative. How do you cancel out the 99 on the right side? Subtracting it, and whatever you do on one side, you do to the other. So that's why on the left side, it became a 3-term expression because there's no like terms on the left. And that's why on the right side, it became 0. 99 minus 99 is 0. The way we're going to phrase the steps, we're going to make it work no matter what happens, no matter what problem we have in front of us. So for step 1, we need to make sure to set the equation equal to 0. So step 1, set the equation equal to 0. Readiness. It might be 0 already, like you can see some of the problems down here are already set equal to 0. Great, that saves us a step. But if it's not, we need to cancel it out by doing your inverse operations. Next, look at the difference from this line to this line. What changed? They put it in factors form. So once you set it equal to 0, it looks like the way that they're solving this is to factor the non-zero side. All right, so not the side that is 0, the other side, factor it out. And that kind of, if you wrote the flow chart from the warm-up, you check for a GCF. Then you see how many terms you have left. In this one, I have a trinomial. So in this one, I could factor it using that same method as before, the diamond method. And I would set it up where we're looking for two numbers that multiply to negative 99. And at the same time, add to negative 2. And it looks like the way that this person wrote it, it looks like they're saying that negative 11 and positive 9 do that. You guys agree? Does that make it work? Does it multiply to negative 99 and add to negative 2? So there's no error there. All right, so if you have a find the error problem, kind of like do the problem yourself and see, are we getting the same thing? So far, no mistake. We factored the non-zero side. Now look at the difference from this line to the next line. How would you put in words what he did? Or tell me in your own words, what's the difference? What changed? All right, so these error analysis or like the proofs that you'll be doing eventually in geometry, you have to ask yourself, like, what's the difference? What changed? I went from having 1 equals 0 to now having 2. That could be a different change that we noticed, right? So put that into words. Don't just wait for me to tell you all the time. Because I have said it before. I even said it in the warm-up today. What they are doing is setting each factor equal to 0. So what are factors? What do we do with factors? What operation of math do we do with factors? We multiply them. So even though it's not just like a single number going on here, we have a parentheses times another parenthesis. So those are factors. So putting each factor equal to 0 is what's going on in step 3. Reason we're allowed to do that is because of the zero product property. That's why they factored it to begin with. Because if I have something multiplied together to equal 0, one of those things has to be 0 to make that happen. To figure out what it has to be, because again, it could be the first parentheses that become 0 or the second. We're setting each factor equal to 0. And then what does it look like we're doing in the last one? How did they go from n minus 11 equals 0 to just n equals 11? They isolated the variable. And the way that I just wrote these steps will work for any problem that we're solving by factoring. Because it kind of just depends what you have. So like here, I have minus 11. I would have to add 11 to each side to isolate it. And then over here, I'm having to subtract 9 on each side to isolate it. It'll change every time depending on what you ask. But you guys know that when you isolate variables, you're undoing what's being done. Okay, questions on that? So now you have 3 problems to try yourself using the steps we just wrote together. So make sure it's set equal to 0. If it's not, then set it equal to 0 yourself with your inverse operations. Factor the non-zero side. We learned how to do that last week. Set each factor equal to 0 and isolate the variable. I'm going to give you 5 minutes to try that before we go over it. This first example. Making it equal 0. Right now it's equal to 5. So class, how can I make that 5 become 0? Subtracting it. And whatever you do on one side of the equal sign. And notice that I'm putting it near its like term. Because sometimes over here, maybe it's like a 5x, and then you have to subtract it from the other x term you have, like they will do that sometimes. But right now it's a single number, so I need to subtract that single number from the other single number. Occasionally, I'll get some students that say, oh, we cancel out the 5 to make it 0, I need to multiply it by 0. While that would make it 0, I then have to do it on the other side, and then I'm no closer to solving anything if everything's canceled out, right? So just inverse operations, usually adding or subtracting to make that equal 0. And then on the left side, combining like terms, 5 what's 12 minus 5. And that's a positive 7, so I'm going to put a plus 7. So that's me setting it equal to 0. Table 5, what would be the next correct step on this one? Nope, they're not like terms, so I can't do that. You guys get stuff, look at the steps that you have to write down, look at your road. Factor the non-zero side, which factoring, it kind of just depends how it looks. So first, check for a GCF. I don't have a GCF. Now check how many terms do I have? I have 3 terms. Class, how do I factor a 3-term expression? The diamond method. So, or in other words, we're finding 2 numbers that multiply to 7 and at the same time add to -8. Table 6, what 2 numbers multiply to 7 and add to -8? -1 and 7. So this would multiply to a -7, so how do I need to adjust this? All right. And now check. Class, does this make it work now? Does it multiply to a positive and add to this negative? So once you find the 2 numbers that make it work, remember that just gives you your factored form. Not your solutions right off the bat. To get your solutions now, you have to set each factor equal to 0, or you could just remember the pattern we've done since unit 6, but set each factor equal to 0 and isolate the x. So in the first one, I'm adding 1 to both sides to get the x alone. So one of our solutions is a +1. And then over here, I'm adding 7 to both sides to cancel out this -7. My other solution is 7. Good. All right, for time purposes, we're going to go directly into this one now. And let's all do it together. So for this one, do I have to set it equal to 0? No, because it's already equal to 0. Great, that saves me a step. The next step, to solve by factoring, I need to factor the non-zero side. So look at it. Can I use the diamond method on this one? No, you can't. You can only use the diamond method when it's a 3-term expression. This is a 2-term expression. The only way I know how to factor a 2-term expression is to 1, check for a GCF. I don't have a GCF on that one. But then 2, apply that difference of squares rule. So, is that last problem a difference of squares? Is it a minus sign in between? Is it perfect squares on each side of the minus sign? Then you can apply that rule. What's the square root of 49? 7. And what's the square root of x squared? So for that difference of squares rule, we put the square roots here, and one of them just has to have a plus, the other one has to have a minus. All right, next you set each factor equal to 0 and solve for what x has to be. So for this one, I have to subtract 7 on each side to get the x by itself. So one of the answers is -7. On this one, I have to do 2 steps technically, but you could also probably guess and check at that point and probably get it right a little faster. But I have to subtract 7 on each side and then divide -1 on each side. And my other solution is a positive term. The middle one is easy. We just, on Monday, you're gonna have time for it. You could see that solution online in Schoology. So it has it has. So this one, set it up, it would be -11 on the top, -10 on the bottom. The only factors of 11 are 11 in itself, but to make it work to where it multiplies to a negative and adds to a negative, the 11 would have to be negative. So this gives us a factored form, x minus 11 and x plus 1. And then again, you could probably guess and check from there, but really we are setting each factor equal to 0 and solving for x. So adding 11 on each side, like that. And in this one, subtracting 1 on each side. And those are our 2 solutions.